Hi everyone. In this videos I'm going to give a talks about a basic course in statistics for everyone towards data science with R. I would like to first give a big picture which includes the presentation of basic topics of statistics with plots, graphs, codes, examples along with the precise definitions and explanations of the concepts with R coding. The coding has two purposes. The first purpose is to learn how to code statistic concepts using R. Secondly, it helps to do plots, graphs, charts, tables, by which one can visualize and consequently grasp the concepts in an effective fashion. As we know, the statistics consists of two parts. Part one, descriptive statistics, which start with introduction to statistics, preview of the basics of R coding, some history, definitions of the populations, samples, parameters, and statistics, and different types of sampling. Then we move on to definition of variables and constants, qualitative and quantitative variables, qualitative variables or levels of basic measurements, continuous and discrete quantitative variables, and finally the definition of tables. Chapter 3 deals with two types of statistics, descriptive and inferential. Descriptive statistics consists of measures of central tendency, measures of variability, five-number theory, concept of skewness, concept of kurtosis, and finally correlations between different variables. Chapter 4 is about probabilities and distributions, starting with definition of probability and move to random variables, conditional probability, and some examples, statistical distributions, central limit theorem and law of large numbers, and finally explaining the Newcomb and Benford's law. Part 2, which is about inferential statistics, is about hypothesis tests, independent samples t-tests, paired or dependent samples t-tests, statistical significance and confidence intervals, estimating parameter values, and effect size. Chapter 6 is about the analysis of variance, one-way analysis of variance, two-way analysis of variance, the chi-square test, and independence of chi-square. Final chapter is a long chapter, consists of models and algorithms. We start off with linear regressions, linear multiple regressions, generalized linear regressions, generalized additive regressions, LM, GLM, Ridge, Lasso, and Elastic Net, time series decomposition and forecasting, time series hierarchical clustering and classification, principal component analysis, anomaly detection, natural language processing, naive Bayes, clustering, decision trees, credit card fraud detection, business analysis, CO2 in international level, credit rating, loan prediction, sales prediction, and finally predicting stock price using FFDT model. Larry Wasserman, a UPMC professor of Statistics and Data Science, Department of Statistics and Data Science and Machine Learning, Carnegie Mellon University, pointed out in his book Statistics for All, quote, statistics, data mining, and machine learning are all concerned with collecting and analyzing data. For some time, statistics research was conducted in statistics departments, while data mining and machine learning research was conducted in computer science departments. Statisticians saw that computer scientists were reinventing the wheel. Computer scientists saw that statistical theory didn't apply to their problems. Things are changing. Statisticians now recognize that computer scientists are making novel contributions, while computer scientists now recognize the generality of statistical theory and methodology. Here we have the many objects in data science, computer science, statistics, which somehow different disciplines use different terminology. For example, in statistics, we have the estimation, whereas in computer science it's called learning. And the meaning is using data to estimate an unknown quantity. Likewise, for classification, computer science uses supervised learning, predicting a discrete y from X belongs to a general space, putting data into groups. Clustering, which is called unsupervised learning, data training sample, covariates features, classifier hypothesis, confidence interval, also confidence interval, directed acyclic graph Bayesian inference, frequency inference, the same frequency inference, statistical methods for producing point estimates and confidence intervals with guarantees on frequency behavior. But finally, large deviation bounds, pack learning, which means uniform bounds on probability of errors. Statistics started in 5th century BC and used for demographic and financial data. Pascal and Fermat, the fathers of probability theory, invented probability theory in 1654 to solve a gambling problem related to expected outcomes. Bernoulli, a 17th century Swiss mathematician, is also famous for Bernoulli trials. Two basic subjects of statistics, descriptive, which describe what is going on in a sample of a population or a data set. Inferential statistics, by contrast, take findings from a sample group and generalize them to a larger population. These measures are important and useful because they allow scientists to see patterns among data, and thus to make sense of that data. Descriptive statistics can only be used to describe the population or dataset under study. Zontuki, known as the great statistician of his times, who made the exploratory data analysis a formal subject of statistics. In 1977, he wrote the book Exploratory Data Analysis, and he pointed out that exploratory data analysis can never be the whole story, but nothing else can serve as the foundation stone. There are a number of items that belong in this portion of statistics, namely the descriptive statistics, or EDA, the average measure of the center of dataset consisting of the mean, median, mode, or mid-range. The spread of dataset, which can be measured with the range or standard deviation. Overall description of data such as the 5-number summary, the minimum, the 20th percentile, the median or 50th percentile, the 75th percentile, and the maximum. Measurements such as skewness. We have here 3 plots of a bell curve. In the left-hand side, we have a curve which is skewed to the right, meaning that it has a positive skew, and in this case, the mode is less than median, and median is less than the mean. In the middle one, which is symmetrical curve or symmetrical distribution, we have mean, median, mode are all the same. In the right-hand side, we have a negative skewed curve, which is skewed to the left, where mean is less than median and median is less than mode. This is the 3 type of normal distribution with skewness or without skewness. We have kurtosis. We have 3 different curves, and the top one, which has the largest maximum point, has positive kurtosis. When it has a positive kurtosis, as we see, there is a big tail in the curve. The normal distribution, which is the curve in blue color, and the curve in green color with minus kurtosis, which the small maximum point but very fat tail. Finally, we have the concept of correlations. Correlations means what happens when one variable change to the second variable, or changing the one variable affects second one or not. It's possible to have the first variable changing, increasing, the second variable also increasing, or vice versa, or there is no effect whatsoever between 2 variables. This is called a Pearson correlation and is defined by covariance divided by standard deviation of x times the standard deviation of y, which is also equal to variability due to codependence between two variables divided by independent variability among two separate variables. Frequency distribution both for qualitative and quantitative data. The Bernoulli distribution is, if we take a p in between 0 and 1, the percentage of success is called Bernoulli Trial, an experiment that has two options or that has two outcomes: success, which is also called true, and failure, which is also called false. And if we take like p is equal to 1/2, we say the probability of getting a success is exactly the same as the probability of getting failure. We have here the Gaussian distribution, the curve including the red area is called standard normal curve, and the area under the curve from -infinity to infinity is equal to 1, and the middle point is mean or mu equal to 0, and standard deviation is equal to 1. As you see, in honor of the Gauss, there is the mark note, German mark note, which is 10 mark. Both the photos of the Gauss and also a graph of the normal curve. If we have on the left hand side, we can see the normal curve with the equation of f of x equal to 1 over sigma times square root of 2 pi times e to the power of minus x minus mu squared divided by 2 sigma squared. This is the equation of the normal distribution, or so-called Gaussian distribution. We have here two more graphs. Here we have one normal distribution with the same standard deviation, but different mu, with different mean by transporting the curve to the right or to the left, by shifting actually to the right or to the left. We have here like 1, 2, 3, 4, 5, 6 different curves. When we have k is infinity with the pink curve with largest maximum, and the largest maximum we have smallest tail, and the less maximum we get the curve with larger tail. So these are the comparison between some of the Gaussian curve, normal curve, with the T or normal distribution to T distribution with K number of samples. This is also a random Eventhal normal distribution, as we can see, which is made of from a water splash. Here we have a Anscombe's quartet, 4 types of data, different data, 4 types of different data. All 4 data sets have the same mean over x-axis, the same mean over y-axis, the same regression line, and the same sum of squared residuals. We will see how to code this in the following sections. Inferential statistics are produced through complex mathematical calculations that allow scientists to infer trends about a larger population based on a study of a sample taken from it, to examine the relationship between variables within a sample and then make generalization or predictions about how those variables will relate to a larger population. Generalize results from random samples to whole populations. Types of inferential statistics: estimate parameter values, perform linear regressions, compute confidence intervals, and perform hypothesis tests. Research of inferential statistics: conduct a test of significance to determine whether they can generalize their results to a larger population. Common tests of significance including chi-square and t-test and parameter estimation. Descriptive versus inferential statistics. Descriptive statistics: no generalization, but precise computation of statistics of samples. Even though inferential statistics uses some similar calculations, such as the mean and standard deviation of population, or the parameters, these parameters are given as a range of potential numbers along with the level of confidence. I think I have leave it there, and thank you very much for watching. In the next video, I'm going to continue this with the graphs, different graphs, and the probability and axioms of probability and distributions, and then we move on to basics of R coding. So see you soon. Bye.